All right, guys, so today what we're going to try and do is something I'm paying off a promise that I made way back at the beginning of the year. I don't like teaching you guys things and not teaching you where they come from. It feels unfair to make you memorize things without myself explaining to you why these things are true. And I made you do that with the distance formula. It was a little unfair. I said, hey, you need to know it, write it down. I promise you, I'll explain it later. Well, now is the time. So let's think, what are the formulas and can we make any connections? Here's the distance formula. Here's what we learned yesterday, the Pythagorean theorem. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Here we have a squared plus b squared equals c squared. So typically when we do this, somebody will say, well, I'm seeing the second power. We're squaring things over here and over here. Oh, yeah, that's pretty interesting. That's pretty interesting. Well, what if we did something like this, you guys? What if we decided to take the square root of c? Wouldn't I then wind up with c by itself is equal to the square root of a squared plus b squared? And now the Pythagorean theorem looks a lot like this, right? This is a constant, and it's set equal to the root of something squared plus something else squared. Interesting. Okay, we're getting closer. But where does this come from? x2, x1. Well, what if we consider this hypotenuse, c, as the distance between these 2 points? This point and this point. That's interesting, right? It's very interesting. Because now I can say, A looks a lot like just the horizontal change in distance. I went from here over to here. So to me, it kind of looks a lot like, oh, I don't know, my change in x, x2 minus x1. And gosh, this sure looks like, the b sure looks like, if this is the second y value, and this would be the first, this looks a lot like y2 minus y1. That is what's being covered in that distance. So suddenly I could say, well, c, which is the hypotenuse, but also kind of just distance between those 2 points, is a squared, but a is really the difference in the x's. And b is really the difference in the y's. So I go, wow. Now I see Mr. Card was not making up the distance formula. It doesn't come out of nowhere. Everything that we're learning in mathematics is something I can prove to you. All right? And you should expect me to do so. So I'm sorry I made you wait so long to learn why this really kind of busy formula over here is what we use, but it comes from this. It comes from saying, instead of anytime I have 2 points, and this is something I'll often say, is from now on, anytime you have 2 points and you need to find the distance, why even bother finding the distance when you can say, well, I could just move over this way, move down this way, and say a squared plus b squared equals, I'll call it d for distance instead of c for hypotenuse. And suddenly, I can use the Pythagorean theorem as the distance formula. It's almost like interchangeable. All right, here's what I mean by this. -5, 1. 5, 1. -5, 6. So could you, if I asked you to, use the distance formula to find this blue line? Of course you could, right? You would use these values that I gave you, -5, 6, and 5, 1, and you'd plug it into the distance formula. Sure, you could do that. Or now that I've shown you the relationship between the two, you could say, wait. How much did I go up from 1 to 6? 5. How much did I go over from -5 to +5? 10. So this distance is really the hypotenuse of this right triangle, right? This, if you think about it, is your x2 minus x1. This, your y2 minus y1. But they're also your a and your b, and your distance is also c, the hypotenuse. So I can go ahead and say, pretty sure 5 squared plus 10 squared equals, I'll call it the distance squared instead of c. Okay, 25 plus 100 equals d squared. D squared equals 125. Gotta take the root. And what have I learned? I've learned how to split this up. I'd say, oh, that's 25 times 5, so that's going to be 5 root 5. And there you go. All right. I hope this video helps in many respects. I hope it shows you, if you're ever in a situation where you forget the distance formula, so you're on the SATs or something, then you can go, wait. I don't need the distance formula. Because distance between 2 points, if I just draw a line straight down and then straight over, I've created a right triangle, and I know the Pythagorean theorem. It's easy. Pythagorean theorem is easier to memorize than the distance formula. So hopefully you guys found this pretty interesting, and I'll end the video there.